Hello and Assalamualaikum everyone. We are Group 1 from CS1124A. We'll present our case study for subject MAT263. The topic of our case study is application of linear algebra using electrical circuit. Before we start, I will introduce my group members, which is from the left is me. My name is Nurul Anis. Secondly, Siti Fatimah Amalina and Muhammad Muiz Fikri. From the bottom, Nadira Akilah, Ilya Khadijah, and the last one is Taufik. So I will start first with introduction. Linear algebra most apparently uses by electrical engineers wherever there is system of linear equation arises the concept of linear algebra. There are two different electrical circuit solutions such as Kirchhoff's law and Ohm's law. The objective of applying these laws to a circuit is to figure out how the behavior of the voltage and currents throughout the circuit. So, for definition of Ohm's law is the voltage across a circuit element which is proportional to the current flowing through that element. Next, the definition of Kirchhoff's law is Kirchhoff's law have one for voltage and one for the current that determine what a connection between circuit elements means. These laws can help us analyze this circuit. So that's all from me. I will pass to Siti Fatimah Amalina to proceed the next topic.
Thank you, Anis. My name is Siti Fatimah Amalina binti Abdul Razak, and I will talk about the purpose of this study. The main purpose of this study is to show the application of linear algebra in the electrical circuit and determine the equivalent currents in the circuit. Besides that, we would like to demonstrate and explain details about the Gaussian elimination method. The theory that will be used in this case study is Ohm's law and Kirchhoff's voltage law. Anis has told us about what is actually Ohm's law and Kirchhoff's voltage law. So, I will tell you guys about what exactly these two laws can be used in our real-life problems. Problems like calculating powers to be delivered to the heaters can be determined by using Ohm's law. To generate the necessary quantity of heat, resistors limit the amount of current that can pass through them. Therefore, we should consider Ohm's law to estimate the quantity of the resistor. For Kirchhoff's voltage law, it is very simple actually. We all know that the electricity in a circuit flows in one continuous direction. When you turn off a light switch, for example, you are breaking the circuit and the light will turn off as a result. When you flick the switch again, the circuit is re-engaged and the light comes back on. Consider adding lights on your Christmas tree or around your house. When one light bulb goes out, the entire string goes up. This is owing to the fact that the power has nowhere to go after being blocked by the damaged bulb. It's the same as turning off the light switch and interrupting the circuit. Then I will pass to Muiz.
Okay, my name is Muhammad Muiz Fikri bin Hanafi. So for my part is methodology. This project, we use Kirchhoff's voltage law and Ohm's law. Kirchhoff's voltage law states that the algebraic sum of the voltage around any closed path in a circuit is identically zero for all time. This indicates that the sum of voltage sources must be equal to the sum of voltage drops surrounding any path in a circuit. While the other law, which is Ohm's law, says that the voltage or the potential difference between two locations is proportional directly to resistance current, or electricity and proportionate directly to the circuit resistance. The picture shows that the loop current and their direction identified. So for the analyzing the circuit is now involved finding out the current flow in each mesh given the value of the voltage sources and resistance. In order to analyze the circuit, Kirchhoff's voltage law must be applied to each mesh. For example, the voltage across 8 ohm would be I1 minus I2 multiplied by 8 ohms. Okay, there are 4 clockwise loops in this circuit. Loop A, Loop B, Loop C and Loop D. if the direction of resistor opposite to the direction of current IR, to the current IR will be positive. So we need to find the value of I1, I2, I3 and I4. Okay, equation for each loop. The first step in solving this problem is to write the sum of voltage around each loop. The voltage sum of each loop must be equal to 0. Okay, we can see the equation all equal to 0, right? Okay, the second step is substitute in all knowns value, put all unknowns current value on one side of the equation, and finally simplify. So you can use this step to other equation loop A, equation loop B, equation loop C and D. So the answer for each equation is I1 is 75 per 32, I2 is -5 per 32, I3 is 25 per 32, and I4 is 15 per 32. And then we use the Gauss-Jordan elimination method to solve the rest of equation. Okay, that's all for my part. I will pass to the other part. Thank you.
From the linear equation, for the first part, we need to form an augmented matrix and then apply Gauss-Jordan. In the first row, the first entry is 9. So we need to get the leading one. We need to divide the first row with 9. And then subtract row 1 multiplied by 8. Subtract row 1 multiplied by 3 from row 3. Subtract row 1 multiplied by 11 from row 4. Multiply row 2 by -9 over 191. Subtract row 2 multiplied by 7 over 9 from row 1. Add row 2 multiplied by 16 over 3 to row 3. Add row 2 multiplied by 176 over 9 to row 4. I will pass to Ilya.
My name is Ilya Khadijah binti Rosli, and I am going to continue on explaining on how we want to solve the problem. Firstly, we look at row 3, column 3. The value is not leading 1. So we have to change the value into leading 1 first. In order to do that, we have to divide row 3 with -191 over 1768. Now our new entries for row 3 are 0, 0, 1, -191 over 221, and 665 over 1768. We have to make sure that all the entries in the column of leading 1 are 0 except for leading 1. Okay, let's look at row 1 first. We need to make sure that the column 3 in row 1 is 0. So we need to subtract row 3 multiplied by 35 over 191 from row 1. And we will get 1, 0, 0, 35 over 221, and 4,275 over 1,768. Now we will look at row 2. We will do the same step as before, which is to make sure that the value for row 2 column 3 is 0. So we need to add row 2 with row 3 multiplied by 45 over 191. Then we will get the new entries for row 2, which are 0, 1, 0, -45 over 221, and -445 over 1,768. Okay, Then we will move on to row 4. For row 4, we need to add row 4 with row 3 multiplied by 2981 over 191. And we will get 0, 0, 0, 7,000, negative 7,180 over 221 and negative 26,925 over 1,768 as our new entries for row 4. After making sure that all the values for column 3 except leading one in row 3 are 0, we need to change the entry for row 4, column 4 into leading 1. In order to do that, we need to multiply row 4 by negative 221 over 7,180. Then we will get 0, 0, 0, 1, 0.46875 as our new entry. Next, we need to change all the values above leading 1 into 0. We need to do it row by row. So now we will look at row 1 first. For row 1, we need to subtract row 1 with row 4 multiplied by 35 over 221. Now our row 1 are 1, 0, 0, 0, 2.34375. The next step is adding row 4 multiplied by 45 over 221 to row 2. And we will get the new entries for row 2 are 0, 1, 0, 0 and negative 0.15625. And the last step for this problem is to add row 4 multiplied by 191 over 221 to row 3. Therefore, our new entries for row 3 are 0, 0, 1, 0, 0.78125. Now, we have transformed the augmented matrix into reduced row echelon form of matrix. And we have obtained the values for I1, which is 2.34375, I2 equals to negative 0.15625, I3 equals to 0.78125, and I4 we have 0.46875. Hence, we can conclude that the system of linear equations is consistent and has only one solution, or we call it as a unique solution. And that is the end for the part of result, and I will pass to Taufik to continue the presentation. Thank you.
Hi, my name is Taufik bin Muhammad Hassan. Today I'll be going to talk about the final part, which is conclusion. As a conclusion, there are several methods for calculating an electrical circuit, including Ohm's law, Kirchhoff's law, using Gaussian elimination method. For this linear algebra problem, Kirchhoff's law and Ohm's law are implemented to find the amount of current for I1, I2 and I3. Kirchhoff's law states that the total current entering a circuit junction equals the total current leaving the same circuit when both input and output are 0, and Gaussian elimination row reduction is used to generate the result from a matrix in the reduced row echelon form. Rather than using the physics method, it is easier to use the metric method to solve the problem since the equations are solvable. Since the electrical circuit used in our everyday life, the expert must be extremely cautious and thorough when performing calculations on an electrical circuit to avoid any problems such as malfunction of the appliance in the future. Examples of the appliance are a water heater, iron, and microwave. That's all from me. Thank you. I will pass back to Anis.
Thank you to Taufik. So these are all the references that we have got for our case study. With that being said, we would like to express our gratefulness to the people that has been helping us throughout the making of the case study and this video. First and foremost, thank you Allah Subhanahu wa Ta'ala for His showers of blessing. Next is, of course, our parents for their love, prayers, sacrifices, and continued support throughout this semester. Besides that, we would like to express our thanks and gratitude to our lecturer, Madam Juvisa, for giving us the opportunity to do this case study and providing invaluable guidance throughout the journey. The most important is, we would like to express our thanks to our classmates, and for CS124A, who will always give us moral support and ideas to continue this case study. That's all from us. Thank you.